During the early 1900s, people had to use ferry boats in order to get across the bay. Ideas of building a bridge had been floating around since the late 1800s. However, serious planning did not start until the early 1900s. The construction on the bridge began 3 years later in 1933. It took only a little over 3 years to complete, with the opening date in 1936. The main components of the bridge consisted of the eastern span, which extended from Oakland to Yerba Buena Island, the western span from the island to San Francisco, and the tunnel through the island that connected the two spans. In the initial plan, the bottom level of the bridge was designated only for buses and trains, and the top was for cars. However, in 1962, this was changed to allow mixed traffic of cars and buses on both levels in order to accommodate the influx of cars due to population increases. In 1989, a major earthquake damaged part of the eastern span. Caltrans, the state's transportation department, rebuilds the collapsed span in a month as a short-term fix. Over the next few years, they develop a plan to retrofit all the state's major bridges, including the eastern span. With abundant analysis, the engineers decided that completely reconstructing the eastern span would be the cheapest alternative in the long run. The complete construction of the new eastern span began in 2002 and was supposed to be completed in 5 years. But disagreements about the design of the new bridge delayed its completion until 2013. It also raised the price tag 6 times over the initial budget. The main question rises, why is there such a big difference in cost and completion time for each bridge? In this video, we will talk about some of these specifics, and how the first bridge was built and why did it take so much longer to build the new Bay Bridge.
The growth in demand of access to San Francisco from the East Bay initialized the design and construction of the Bay Bridge. The design was 8.4 miles long, which consisted of the western span and an eastern span. So the western span, which is still there today, was a suspension bridge, and the eastern span, which eventually got replaced, was a cantilever bridge. The reason they chose a cantilever bridge at that time was that the suspension bridge was not going to be able to handle the rough conditions of the bay. So the construction, as said, it was started in 1933 and only took 3.6 years. And the reason for that is they had almost 9,000 workers at that time. During that time, safety regulations were not in place, and it was very dangerous and risky for workers to be working on the bridge. In result, 24 workers died by the end of the construction of the bridge, which was way better than what they expected. At that time, they were expecting at least one death for every $1 million spent. Since $77 million were spent, they expected 77 people to die at that time. The reason for fast design process was that engineers and contractors were well respected and their designs were respected. Nobody went in their way of telling them how to design it. And at that point, nobody really cared about how the bridge looked. What they really cared about was the functionality of it to get them from point A to point B, which is from the East Bay to San Francisco, and from San Francisco to the East Bay. Since at that time, political officials and public officials didn't get involved in the bridge design, not that much delays occurred, and that's why the bridge was able to be built in the timely manner that it was compared to the new eastern span of the Bay Bridge.
In 1996, a replacement of the Bay Bridge's eastern span was announced, with a $1.3 billion budget. Instead, it became a $6.4 billion 11-year project. The replacement bridge was given a $1.3 billion budget for a proposed simple skyway. Politics quickly got involved and disagreed with the simple bridge that legislation passed, and called for a more iconic structure to rival the Golden Gate Bridge. This got further complicated when the mayors of San Francisco and Oakland gave their input. San Francisco opposed the alignment of the new bridge on Yerba Buena Island as it would interfere with their plans for a casino on the island, and Oakland thought the design should be more aesthetically pleasing. 2 years of construction time alone was lost over the alignment of the Yerba Buena Island. Time equals money, and with such a big project as the new Bay Bridge, this meant billions of dollars. A new self-anchored suspension bridge design was chosen in 1998, and by 2001, construction still hadn't begun. Yet the cost had somehow jumped to $2.6 billion. According to Berkeley professor and civil engineer William Ibbs, these issues are due to optimism bias. This was the first time they had a project of this caliber, and they underestimated the costs. The further into the project they got, the more complications they ran into. Legislature was also a big cause for the time and money lost. Caltrans had to ask for more money from legislation every time a new estimate came. Instead of moving forward with the project, Caltrans was sent backwards to the drawing boards to review more economical designs. In the end, the project lasted 11 years, opening in 2013 with a final cost of $6.4 billion. The new Bay Bridge is estimated to have a life of 150 years. Due to the innovative engineering and design, the Bay Bridge will remain an iconic structure to the Bay Area. Future generations will be using this bridge for years to come.
Engineers reconstructed the eastern span to combat future earthquakes with a structure that is more flexible, so the bridge will sway with the seismic waves rather than collapse. The Skyway's foundation is stabilized with 160 concrete-filled steel piles in rebar. The engineers used the process referred to as battering to drive these piles into the sturdy soil up to 300 feet below the bay's surface at an angle. Although the method had never been used for constructing a bridge, the engineers considered this to be more stable than the more conventional methods that they used to use. The piles are also relatively flexible, so they can absorb the seismic energy. The bridge also contains 20-inch pipe beams that are 60 feet long between its deck sections. These beams allow the sleeves of the structure to expand and contract for changes, such as in temperature or during earthquakes. The tower consists of 4 steel shafts with shear links connecting them. The shear links are located at precise places along the tower that are created from a specific grade of steel, which is more elastic. This allows the engineers to decide how the tower will yield during an earthquake. It will bend at these points and prevent the major motion from being absorbed in the foundation and the road decks. However, on an average day, these shear links will actually strengthen the structure. In conclusion, the main difference between the two construction and design processes dealt with politics and new evolving technology. Since politics did not interfere with the old bridge design, the construction process was completed without any delays. Furthermore, the new bridge focused not only on functionality, but form as well. This fixation on appearance and design led to a back and forth between several competing structural designs, causing delays and overspending. The old bridge's main focus was functionality without the goal of an iconic structure. All in all, with evolving technology, projects are becoming more costly and lengthy. This is due to technological advancements as well as public and political disagreements which extend projects.